Welcome back to the series. Now we will continue with additional exercises of chapter 5. So let us see question 5.24. Figure 5.17 shows the position time graph of a body of mass 0.04 kg. Suggest a suitable physical context for this motion. What is the time between two consecutive impulses received by the body? What is the magnitude of each impulse? So it is moving for 2 centimeters, then moving back, moving for 2 centimeters, then moving back, and that is happening every 2 seconds. So let us find the magnitude of its velocity. So velocity would be its slope. So velocity is 1 centimeter per second. 1 centimeter per second minus 1 centimeter per second, 1 centimeter minus 1 centimeter per second, and so on. Okay, so this could be motion of a ball bouncing between two balls. So if two balls are 2 centimeter apart and the ball is bouncing between them, that could be its motion. Okay, motion of a ball bouncing between two balls which are kept 2 centimeter apart. So let's say two planks are being kept or two books are being kept and the ball is bouncing between them. So what is the time between two consecutive impulses received by the body? So time is 2 seconds. So time between two consecutive impulses is 2 seconds. And what is magnitude of each impulse? Magnitude would be change in momentum. So change in momentum is 0.04 multiplied by, that is mass, multiplied by change in its speed. So it would be 1 to minus 1. It is going from 1 to minus 1. So change in speed is 2 centimeter per second. So it is 2 into 10 to the power minus 2 kg meter per second. So it is 8 into 10 to the power minus 4 kg meter per second. So that is the impulse faced by the body. That is the impulse, and this impulse is being faced, this impulse is being imparted every 2 seconds. Let us move to the next question. 5.25. Figure 5.18 shows a man standing stationary with respect to horizontal conveyor. See, he is stationary with respect to the conveyor. So the person standing on the ground, he will be moving. And the conveyor belt is accelerating with 1 meter per second square. So with respect to ground, the acceleration of the man is 1 meter per second square. What is the net force on the man? So because the man, let us consider the body of man. So man is accelerating to the right with 1 meter per second square, and because the normal and its weight would cancel each other out, the net force would be mass of the man multiplied by acceleration. So 65 into 1, 65 Newton. So force experienced by the man is 65 Newton. If the coefficient of static friction between the man's shoes and the belt is 0.2, so coefficient of static friction is 0.2. So what will be the maximum frictional force? Max friction would be 0.2 into mg. So it would be 2 into 65, which is 130 Newton. 130 Newton would be the maximum frictional force. Up to what acceleration can the man continue stationary relative to the belt? So this is maximum friction. So let us find the acceleration which will be caused by maximum friction. So acceleration would be 130 upon 65. So it would be 2 meter per second square. So up to 2 meter per second square, the man will remain stationary with relative to the belt. But if the acceleration of the belt exceeds that, the man will start slipping. And the man will move with relative to the belt, because the frictional force will not be able to accelerate man any further. So this is the limit of the acceleration. Easy enough. Let us move to the next question. 5.26. A stone of mass m tied to the end of a string revolves in a vertical circle of radius r. It is revolving in a vertical circle of radius r. revolving in vertical circle of radius r. Net forces at lowest and highest points. We have to find net forces at lowest and highest point. So let us first calculate at the lowest point. So at the lowest point, what all do we have? We have tension T1 upwards, and mg downwards. So net force would be T1 minus mg. Okay, because it is moving in a circle, the stone will have an acceleration upwards. So the force would be T1 minus mg. For max height position, tension is downwards T2 and weight is also downwards mg. So net force would be T2 plus mg. So for lowermost position, T1 minus mg. For uppermost position, highest position, T2 plus mg. Okay, let us move to the next question. Question 5.27. A helicopter of mass 1000 kg rises with vertical acceleration of 15 meter per second square. So if this is the helicopter, it is rising with an acceleration of 15 meter per second square. The crew and the passengers weigh 300 kg. So mass of people 300 kg and mass of helicopter is 1000 kg. You have to give magnitude and direction of force on the floor by the crew and the passengers. So if we consider crew and the passengers, the normal due to the floor of the helicopter is accelerating them to a 15 meter per second square. So if we consider this crew and the passengers, this is the normal force due to the floor. They have their mp into g, their weight, and they are being accelerated at a is equal to 15 meter per second square. So mp into acceleration is caused by normal minus mp into g. So normal force would be mp a plus g. So mass of people, which is crew plus passengers, is 300 kg multiplied by acceleration is 15, g is 10 into 25. So this is 7500 Newton. 7500 Newton, and it is upwards. The direction is upwards. 7500 Newton upwards. Now the second part, action of the rotor of the vehicle on the surrounding air. Action of rotor of the vehicle around the surrounding air. Now the rotor will push the air downwards. And by how much? So it has to push the air downwards by a force with which it has to lift itself upwards. So the total lift would be Total lift would be 1300 mass of helicopter plus passengers multiplied by acceleration plus acceleration due to gravity. So this is 1300 multiplied by 25. 25 3 is 75. 5 7 25 and 25 plus 7 32. So this would be the force. Now action on the air by the helicopter rotor will be downwards. And force on the helicopter due to surrounding air due to third law of motion by Newton would be upwards. So 32500 Newton, because the reaction force by the air is lifting the helicopter. Understood? So first one, 7500 Newton upwards, because normal of the floor, that is carrying the people upwards. The rotor is pushing the air down. So 32500 Newton force downwards, and the reaction force from the air on the rotors on the helicopter would be upwards, and it will be equal in magnitude. Clear? Let us move to the last question that we will cover in this video. 5.28. A stream of water flowing horizontally with a speed of 15 meter per second gushes out of a tube of cross-sectional area 10 to the power minus 2 meters square and hits a vertical wall nearby. What is the force exerted on the wall by the impact of water, assuming it does not rebound? So, water is coming out of the pipe and hitting a vertical wall. So, we have to find force exerted by the water on the wall. So, first we will calculate what is the mass of the water that is exiting the pipe per second. So, that would be volume exiting the pipe per second. Volume exiting pipe per second, that would be 15 meter per second, that is the speed of the water, multiplied by 10 to the power minus 2 meter square area of cross section. So this is 0.15 meter cube per second, that is the volume of water. Now we know density of water is 10 to the power 3 kg per meter cube. Therefore, rate of flow of water is volume rate multiplied by rho, which is density. So this would be 10 to the power 3 multiplied by 0.15. So this is 150 kg per second. So 150 kg per second is the rate of water coming out of the tube, and it is hitting the wall at a speed of, velocity is 15 meter per second. Therefore, force would be rate of change of momentum, that is change in momentum per second. So it would be rate of mass multiplied by velocity. So it would be 150 multiplied by 15. So it would be 2250 Newton. So it would be 2250 Newton. So force being applied by the water coming out of the pipe on the wall is 2250 Newton. Hope you understood all of these. Let us meet again in the next video.